goes on. Okay, so on Friday we did a little bit of 10-2 notes, so we're going to finish those up today. And if we can get this to clear out. And there we go. Okay, and then we'll do 10-3 notes today too, okay? So, Emily, sit up, please. Okay, so what's the first step when we get ready to solve these addition and subtraction of rationals? What's the first step? Do what? Factor what? The denominator. So what does 20, what multiplies to 20 that adds to -9? -5 and -4. What multiplies to 25 that adds to -10? Good, -5 and -5. Okay, did I work this one on Friday? I started it, did I finish it? I didn't finish it. I think I just got you started on it, didn't I? Okay, so now we have to, after you factor the denominators, you have to build a new denominator, and everybody gets represented in that new denominator. So this x minus 5 gets represented. The x minus 4 gets represented. But what I was trying to show you on Friday was that when you have twins, and I don't know what else to call them, but, you know, identical binomial factors is what they're probably called. Okay, when you have twins, then you have to make sure each twin is represented. So we need another x minus 5 down here, okay, because twins are inseparable, right? They like to be together. Okay, now we play the what's missing game. So from this denominator here to this denominator here, what's different and what's missing from up here? Yes, one of the x minus 5s, okay? So if you were confused about that and thinking, oh yeah, well everything's accounted for. No, we have to, it's a one-to-one thing. This binomial is here and it's here. This one's here and here. This x minus 5 doesn't have a buddy up here. So he is missing. So we multiply this numerator by x minus 5. Okay, so lucky for us, multiplying by 1 is super easy. Now we have a minus here, so when there's a minus, your brain has to take a really good note of that and make sure that you are being careful. Okay, so then from this denominator to this denominator, what's different? The x minus 4, good. Okay, so we're going to multiply this times x minus 4, except it's really a -5, isn't it, because of that minus there? I just kind of moved that negative over so it could be a little bit closer to the 5. Okay, so what's -5 times x? And then -5 times -4 is +20. So we're almost done. We got the hardest part done. We just need to combine like terms here. So what's 1x minus 5x? -4x. And what's 20 minus 5? What's 20 minus 5? 15. Do 4 and 15 both divide by the same thing? In other words, can we factor this numerator right here? Can I factor that? No, because 4 and 15 don't divide by the same thing, do they? So we're finished. So because the last step is to factor the numerator to see if it can cancel out with something in the denominator, okay? And it doesn't. All right, so let's do this one. What does x squared minus 9 factor to? Yes, that's one of those super easy ones to factor. So make sure you're factoring. Okay, so then we have to make sure that everybody is represented in our new denominator. Do I list this x minus 3 twice? No, he's only once here, he's only once here. The reason I listed these x minus 5s twice because there were 2 in one of the fractions. Okay, so comparing this denominator with this denominator, what's different? What's different? Nothing. So I don't multiply that 8x by anything. Again, I have a minus sign, so that tells me to be super careful. Okay? So x minus 3, comparing that to x plus 3, x minus 3, what is different? Or what's missing from up here? The x plus 3 is missing, okay? So we're going to multiply this times x plus 3. Now, pay really good attention here. We need to multiply this binomial times this binomial. I've got that going on, plus I've got this minus sign that I've got to kind of incorporate over here and distribute. So I would only do one of those at one time. I would probably do this. Make a subtraction sign there for the subtraction that's here. And then multiply by my binomial. In other words, do FOIL on it. And then I'll distribute this negative here in a second. That way you don't have to take care of a bunch of things at once. Okay? So forget that minus sign for right now. Just make sure you write it here. So x, when we multiply binomials, and we don't have any leading coefficients here, they're super easy. There's actually a shortcut. You know the first term is x squared. How do you get the middle term? Yeah, you add them, okay? We add them so we get a negative 4, and you just have to remember to put an x, okay? Because, guys, remember, when you're over here and you're trying to take it apart, you're trying to do the opposite, you're saying what adds to the middle term that multiplies to the last term. Okay, so now you're going to multiply these two, and you get negative 21. Now let's distribute that. So this one's causing us a little bit of grief, but we can deal with it. Okay, so we're going to distribute this negative. In other words, everybody's sign's going to change, right? Plus 4x plus 21. Okay. Now in the numerator on the top here, what do we need to do? Combine like terms. Good, I heard somebody say it. Now just be careful because that's a negative x squared. And what's 8x plus 4x? Plus 12x, good. And then plus 21 over x plus 3, x minus 3. Now, all year long, we've said don't start out your x squareds with a negative. I might just let you keep it there. You could change everybody's sign. But what is for sure the last step you need to check and see what's happening? What do we need to do here with either one of these numerators? We need to see what? If it factors, that's right. So, what multiplies to 21 that adds to 12? What are the multiples of 21? 7 and 3. Does 7 and 3 make 12? And then 21 and 1. Does 21 and 1 make 12? No. So neither one of these factors, so we don't have to worry about the signs. So you can have either one of these, okay? In my book. On a multiple choice test that came from the district or something, they might change it where it doesn't start out with a negative. I don't know, but I think you'd be able to, if you got this far, I think you would be able to see that would be the answer. Okay? Okay, so that is 10-2. So now you're going to look at notes for 10-3. Okay? So this one was a good one to work. I liked number 8. It took us a little bit more time, but okay, let's see if we can clear out some of the fantastic work we did first period. So slow. Okay, then, and we're not going to do all of these problems. Okay, again, on these right here, they're just reminding us that if you have the same denominator, you just use that denominator and you just do what you need to do for the numerator. 6 minus 7 is -1. Same here. If you have this, if the denominators are the same, it's no big deal. And then so we say 9 plus x minus 4. What's 9 minus 4? A positive 5. Do I cancel out this x and this x? No. This is a binomial. This is a monomial. You can't cancel out binomials with monomials. Okay? Mono means 1. We talked about that one day. Okay, so moving right along here. Problem number 3. Now, these denominators aren't the same. We notice a minus sign in the middle, don't we? So we know we're going to have to be careful. Okay? So neither one of those factor. That's the very first step. If you forget your steps, you go back to your pink 10-1 notes. You have all the steps written down. I kind of simplified them and made them a little bit shorter, hopefully so you can understand them a little better. Okay, so x plus 2, x minus 2. Everybody's represented in our new denominator. First step was to see if those could factor. They don't. So the next step is to build your new denominator. Okay? Comparing x plus 2 to x plus 2, x minus 2, what's missing from up here? X minus 2, good. So we're going to multiply this 3 times x minus 2. And that gives us 3x minus 6. Okay, so we have a negative 8 here. We're going to have to be careful with that. Make sure we call it a negative 8 instead of a positive 8. So comparing x minus 2 to x plus 2, x minus 2, what's different? The x plus 2. Okay, so now remember, that's a negative 8. So negative 8 times x is negative 8x. And then negative 8 times 2 is negative 16. Very good. So we've done the hardest part, I think. Now all we do is in the numerator combine like terms. What's 3 minus 8? Negative 5x. Good. And negative 6 minus 16 is negative 22. Can 5 and 22 both divide by the same number? No. So they don't factor. You always got to check to see if they can factor. Okay? Okay, so I'm not going to work number 4 because number 4 is just like number 3. There's no surprises or anything different in there that I can see. So there's no sense in working number 4. Okay, questions so far? Number 3? Okay, you've got to kind of get the steps down. What to do, what to do, what to do. Okay, so number 5 is a good one to work because what's happening here? What's the very first step when we're trying to add or subtract these rationals? What can I do here? I can factor that. They both divide by 2. And so we get 2 times x minus 3. What can these both divide by? 4. So I get 4 and then x minus 3. So now we have to build our new denominator. I definitely have an x minus 3 and I have a 4. Do I need to write the 2 again? No. Why not? Because why? Where is that 2? It's inside that 4. Because if I factor 2, if I factor 4, I get a 2 and a 2. So 2 is really inside that 4. It's like written in secret code. It's encrypted in, invisible ink or something like that, right? It's in there. Okay, so this is kind of a little bit new. I think we had one other problem. So comparing 2, x minus 3, to 4, x minus 3, what's different? Yeah, the 2 and the 4 are different. Okay, so in this case, the question we really have to ask ourselves is, what do I multiply 2, x minus 3, what do I multiply this by to get to this? A 2. Okay, if I multiply this 2, x minus 3 by 2, it'll give me 4, x minus 3. So that's what I multiplied this by up here, a 2. So in this case, it really didn't help a whole lot to say what's missing or what's different. We had to change the question around a little bit and say, what do I multiply it by? Okay, and sometimes that happens. Okay, and then from here to here, from 4x minus 3 to 4x minus 3, what's different? Nothing. So we don't multiply that by anything, but we have our good old friend, the subtraction sign. So we have to make sure we distribute that. So let's get all this done at once. So we have 2x minus 10, right? And then, I'm going to erase this because it's going to blend in. Okay, and then a negative x plus a 7. Anybody lost there? Need me to go back. Okay, so what's our last step here? Combine like terms in the numerator, right? So what's 2 minus 1? Is 1x, good. And then negative 10 plus 7, negative 3. And then we have 4x minus 3 here. Oh, look, what can we do? Yes, these x minus 3's will cancel out. So what is our answer? 4? My answer's 4. Don't say your answer's 4, you'll get it wrong after all that nice hard work. You don't want that to happen. Make sure that you put a numerator on the top if you don't have one, and that numerator would be a 1. Okay, so there was a couple of little things different about this one. We had where we had to have the 2 was kind of within the 4, and then at the very end, the numerators and denominators canceled out a little bit. Okay, so let's look at question 6, and then we'll be good to go for y'all to have some work time. Okay, so x squared minus 4, how does that factor? X plus 2, x minus 2. That's one of those difference of two squares that y'all are getting better at. Y'all are getting better at recognizing those. Okay, so building our new denominator, we have x plus 2, x minus 2. Do I need to write x plus 2 again? No, not in this case. I don't see any identical twins anywhere. Okay, so comparing this to this, what do we get? What's different? Nothing. So we don't multiply 2x squared minus 16 by anything. Now, you might have been tempted to want to factor this at the beginning, but don't. We don't have to factor the numerators. We only have to factor the denominators. Okay? So we get 2x squared minus 16. And then, if we compare x plus 2 to x plus 2, x minus 2, what's different? Or what's missing from up here? Okay, you taking notes, Sabian? Okay. Okay, the x minus 2 is different, so we're going to multiply this times x minus 2. Now, lucky for us, we have a nice plus sign here, don't we? So we don't have to worry about that. So we're going to put a plus. Whoops, that's kind of large plus. And then we're just going to do our FOIL on it. Okay, and when you just have plain x's, FOIL should be pretty easy. You just say x squared, and you add the numbers. What's 4 minus 2? Okay, so a plus 2x. You got to remember to add your x. And then you multiply your numbers. Okay, so then what's the next step? Combine like terms across the numerator. Good job. So 2x squared and 1x squared is 3x squared. What goes after your x squareds? Your x, and we only have one x, so we have 2x. And then what's a negative 16 and a negative 8? Negative 24 over x plus 2, x minus 2. What's the very last thing that we need to check? Does that factor? And that's a mess. Okay, it starts with a number, a 3. So we have to say what multiplies to, okay, what's 3 times negative 24? You have calculators on your desk, guys. Come on. Negative 72. So what multiplies to negative 72 that adds to 2? So we don't have this come up very often. We don't have a 72 come up very much. But you have 1 times 72. We're looking for something that might have a difference of 2, right? Okay, 2 times 36, good. 3 times 24, we knew that because it just happened. Okay, 4 times 18. I had first period to find that one. I knew it divided by 4, but I'd forgotten what it was. Okay, 5, it 1 divided by 5. 6 times 12, 7, no, and 8 times 9. So none of those have a difference of 2, do they? So that doesn't factor. So you're like, oh, well, I wasted all my time. No, you didn't. You have to check it anyway, because if it were to factor, something might cancel out. And so you definitely want to see if something cancels out. So that is your final answer on number 6. Okay? Questions on that? Okay, so, oops.